Hi, and welcome to today's lesson on solving linear equations. This is part 2. So if you're working on that topic in Study Island, solving linear equations, you're going to want to make sure that you watch this one and the part 1 video so that you're getting all the information you need to be successful at those questions. So in this part, we're going to be looking at how to solve equations that have two variables, x and y, and how to do word problems and tables. So once again, just remember, don't try doing these problems in your head. Make sure you write down all of your work and make sure you are writing down notes in your math notebook as you watch this lesson. And don't forget, if I go too fast, you can always pause and rewind and take it at your own speed. And you can even pause at the beginning of a question, work the questions out and see how you do. And that way you know how much you still have to learn and how much you've already learned. So I'm glad that you're here, and let's go ahead and look at some examples.
These first examples that we're going to look at involve solving linear equations that have two variables. So in this equation, I have an x term and a y term. And the question is asking which of the following is a solution to the equation below. So here I have a list of coordinates, and remember, your coordinates are always an x term and then a y term. So all these numbers at the beginning are x numbers, and all these numbers at the end are y numbers. It's in alphabetical order. So what I'm going to have to do is I'm just going to have to try out each one of these problems. So I'm going to substitute my x numbers in for x and my y numbers in for y. So I'm going to go ahead and try out letter A. And so my equation is 4x, but this time instead of having an x number or writing x, I'm going to write my x number, negative 18. Then it's a plus 5y, but I know the y that I'm trying out is 14. So I'm going to substitute 14 in for y. And it equals 20. And so what I'm going to do is it's just like checking other equations you're solving. I want to see if I can make this left side the same as the right side. So I'm going to deal with each one separately. So I'm going to work with this left side first. And I'm going to do order of operations. So there's no parentheses, no exponent. So I'm going to multiply and divide left to right. 4 times negative 18 is negative 72. Plus the 5 times 14 is 70. And then I'm going to add negative 72 and 70, and that's negative 2. Then I look at my right side, it's just 20. Negative 2 doesn't equal 20. So A is not an answer. It doesn't work out. So then I'm just going to have to repeat the process with B. I have 4 times, and in B, my x number is negative 13. Plus the 5 times my y number, and my y number here is 19. And I'm going to see if this time I can get that equal to 20. So once again, I'm going to do multiplication and division first, right to left. So 4 times negative 13 is negative 52, plus 5 times 19 is 45. Negative 52 plus 45 is negative 7. And then on my right side, I have that 20. Negative 7 doesn't equal 20, so B is not an answer. So then I just have to repeat the process with C to see if I can get C to work. So C, I have the 4, but this time my x number is negative 15. So I substitute that in. And then I still have my plus 5y, but my y number here is 16, so I'm going to substitute that in. And I still want to see if I can get that equal to 20. So I'm going to work with my left side. 4 times negative 15 is negative 60. And then that 5 times 16 is 80. Negative 60 plus 80 is 20. And my right side is also 20, so this one does check out. So my answer here is C. And if you want to be extra sure, which I really recommend, you can go ahead and try out D also, just to make sure it doesn't work, just in case you made a mistake somewhere in C. Number 3 is another equation that has both a y term and an x term, but it's going to be a little bit less work because of the way the question is worded. It says, what is the value of y when x equals 7? So they already tell me what my x number is. I only have to find the y number this time. So what I'm going to do, since I know this x number is 7, is I'm going to replace the x, all the x's in the equation with 7, which is this one right here. So I'm going to have y equals 3, but instead of writing x, I'm going to write 7 in its place, plus 3. And now I'm just going to simplify it as much as I can. I just have the y on my left side, and then on my right side, I have multiplication and addition. I'm going to do multiplication first. 3 times 7 is 21, plus 3, and 21 plus 3 is 24. So y equals 24. That's the value of y it's asking for. So my answer here is C. In this section, you could also be asked to solve equations from word problems. So you have Alex is flying 2,025 miles. The table below shows the number of miles left to go after each hour of travel time. So here's the table. We have our x's as the hours, and our y's is the miles. If Alex continues at the current rate, how many miles will he have remaining after traveling for 8 hours? So I brought up a calculator because we're going to want to see if there's a pattern with these numbers. Now on the x side, you can see that it's increasing by 4s. Now on the y side, we want to see if they're decreasing at the same rate. And if they are, we're in luck. So I'm going to take 1,828 minus 1,631, and that equals 197. So this is going down by 197. And I just want to see if that holds true for every line here on out. So I'm going to take 1,631 minus 1434, and that matches my 197. So I'm going to check out the last one. I'm going to take 1434 minus 1,237, and that checks out the 197 also. So each of these decreased by 197, so that means I just need to continue this table out until I get to 8. So I have 5, 6, 7, 8. So if I take 1,237 and subtract 197, it's going to give me 1040. And if I take 1,040 and subtract 197, that's going to get me 843. And if you get 843 minus 197, this is going to get me 646. I'm just continuing the table out. And then 646 minus 197 is 449. So that is how many miles he'll have left after traveling for 8 hours. So my answer here is D. I'm going to use a similar approach with this one. Timothy has a savings account. His balance is $600 when he decided to start making weekly deposits. The table below shows the value of his amount, Y, after each weekly deposit, X. So if his account continues to increase at the same rate, what will be the value of his account after making his 6th deposit? So each of these the x column here is increasing by 1s. So I'm going to increase those deposits out until I get to 6. And now I need to make sure that this y side follows a pattern. So 900 minus 750 is 150. So this is increasing by 150. Okay, let's just double check that it follows through the whole table. 900 plus 150, that's 1050. 1050 plus 150 is 1200. And you could use a calculator at any point to double check yourself here. 1200 plus the 150 is 1350. Then 1350 plus the 150, that's going to be 1500. So after 6 deposits, he's going to have $1,500 in his bank account, letter B. Here's a word problem without a table. So let's read. Cassidy is going to the county fair with her friends, but can only stay at the fair for 5 hours. The fair offers 2 different pricing structures. Cassidy can purchase an all-day pass with unlimited rides for $45, or she can pay an admission fee of $9 and pay $3 for each ride. If Cassidy rides 12 rides, how much does she save by buying the all-day pass? So she has 2 options here. If she pays for the all-day pass, she pays $45 for a one-time fee and she's done. Okay, or she can pay a one-time fee of $9, but then she has to pay $3 for each ride. She wants to ride 12 rides. So for each, that's kind of those are keywords for multiplication when you see those in a word problem. So if she does 12 rides and they're each $3, that's going to be 12 times 3, which is $36. So if she goes that route, she's going to pay $9 in admission and $36 for rides. So to get the total, we're going to add those together, and that's $45 also. So she plans on riding 12 rides. Either way, she pays $45. So they are going to be both the same, letter A. Okay, in this example, you're asked to evaluate a function, but the function is given to us in table form. So if we remember back to function notation, this is the name of it. So we're calling this function f of x, and it wants you to evaluate it when x is 0. There's an x in parentheses in the name. It got replaced by a 0. So it wants to know what is this function equal to when x is 0. But in our x column, there is no 0. So we're going to have to continue the table either back up or down until we get 0. Well, if we look at our x column, it goes -3, -2, -1. So if those numbers are getting closer to 0, it's increasing. So if I continue this side, the next one up is 0 if I continue the pattern in the x's. So I'm just going to continue the table on the f of x side, or this is also the y side. F of x is another name for y. So -17 to -11, that's getting closer to 0, less negative, so that's increasing by 6. -11 to -5, that's also increasing by 6. So -5 plus 6 is a +1. So that means when x is 0, f of x is equal to 1, or y is equal to 1, which is our answer, D. The trickiest part about this is understanding the symbols and what the question is asking for. So make sure you keep that straight. And I hope you learned something today, and I really appreciate you tuning in.